Because snipers have been using the literal curve of the earth to plan where bullets go. That's how you plot out. You have to. When you shoot at a mile, you know, when you're shooting like well out over 1,000 yards, those factors.
All right, one of the things that pops up in every one of our long-range rifle classes is Coriolis effect and spin drift, okay? It's in every ballistic program. It's out there. It's in some manuals, and it's theory. Okay, here's where I'm coming from. I was on several long-range rifle and sniping type web pages where there's interaction between the folks that are on them. And a question came up from a kid that was a brand new Army sniper. He was getting ready to go to sniper school, and he was worried about how he was going to pass this course. So of course he put it out there to any Army snipers. Hey, what am I going to get to go through? What do I need to work on? And one of the answers he got really pissed me off. It was, you need to worry about Coriolis and spin drift more than anything else. Now, given the plethora of other information, mathematical equations on range estimation, sight alignment, sight picture, breathing, trigger control, follow through, prepping for the next shot, all these things result in quality accuracy downrange if you do them properly. Coriolis and spin drift are theory. Okay, whether you want to agree to this or not, it's somebody's mathematical theory.
You have to when you shoot at a mile.
So as the bullet leaves the barrel of the gun, the earth is still rotating, and the bullet is not rotating with the earth. So the earth will actually rotate out from underneath of the bullet while it is in flight.
Whether you want to agree to this or not, it's somebody's mathematical theory.
We are all moving with the earth at 800 miles an hour.
So as the bullet leaves the barrel of the gun, the earth is still rotating, and the bullet is not rotating with the earth.
We are all moving with the earth.
You have to when you shoot at a mile.
You apply the fundamentals of marksmanship properly. Crosshairs where they need to be. Do the right dope on the gun. Fire the shot effectively. You're going to get a good hit on target. We're back to the errors involved at the ranges again. We'll use 500. Doesn't matter if you are 1.5 inches left or right of your aim point, in this case at 500 yards. Absolutely not. Still a killing shot. At 1,000 yards, 10 inches may have an effect, but I'm back to the wind again. Is it not you calling a bad wind call, or is it spin drift?
So the earth will actually rotate out from underneath of the bullet while it is in flight.
I'm not going to talk about how this guy did the Red Bull jump and somehow the earth didn't rotate out from under him. I'm going to talk about something that I know about. I was in the military, in a Ranger battalion, in a long-range reconnaissance surveillance unit. Went to various schools, and I've done my share of shooting a lot of different weapons. And I went to a lot of different schools explaining target acquisition. Even after my military service, I continue to be a firearm enthusiast, and I reload my own ammunition, which means I have a very good understanding of internal ballistics. And also, when it comes to in the field, I can use my reticles and calculate yardage and calculate compensation and compensate for the wind quite well. I know how to use a reticle to determine yardage and use that to hit a target in high wind. And at 500 yards, I can yield a target like this pretty consistently. But here's a drill I want to do to obviate the problem with what they teach about the Coriolis effect. I picked Singapore because it's on the equator. And we know that on the equator, the Earth is spinning at about 1,000 miles an hour. There are a few equatorial cities, but this is a good one because it's also on the water. There happens to be a lighthouse in Singapore also, which makes an excellent stationary target. This is called the Marina Lighthouse in Singapore, within 1 degree of the equator. So let's bring in the shooter who's going to hit this target. Meet Mr. New Jersey. This is one of the biggest battleships ever made. It has a 16-inch gun that can reach 25 miles. I've seen specs that say up to 28 miles, depending on the ammunition, but here's a quick snip of some proof. They're saying that bullet actually goes almost 2,700 feet per second, and here they claim 24 miles. I've seen different ones. The weight of that bullet is a ton. Here's a picture of an old decommissioned barrel with a mock projectile to give you an idea of the size of this gun, because this is what we're going to hypothetically set up as a scenario to hit that lighthouse. Here's one of the projectiles in the magazine tube where it would feed up to the gun, And once it gets up there, they pack hundreds of pounds of powder behind that bullet. It's one of the more impressive guns anyone could ever see fired. When they pull the trigger, the explosion is so enormous that it sounds like it's the end of the world. When you see them fire them off from the air, you can see the decompression of that barrel gas make a shockwave across the water the size of a football field. So you aim at your lighthouse 25 miles away, you pull the trigger, boom, it should fall to the ground, right? Well, not exactly. We got a couple problems with this, and let's use math. 25-mile target from the New Jersey has a flight time of 90 seconds. So you're aiming 90 degrees from the ship straight to the equator to hit that lighthouse, and it takes 90 seconds for the bullet to get there. Problem is, in 90 seconds at the equator, the Earth moves 25 miles. So it takes 90 seconds for the bullet to get from the ship to the lighthouse, but in that 90 seconds, the lighthouse moves 25 miles. So you're going to miss it by 25 miles. Now, those are nice numbers to work with because it sets up a triangle. And you can do a little math to go, well, could I actually lead the target and compensate for the Earth spinning underneath of it like they say you have to? Well, how far is it? A squared plus B squared equals C squared, which will give you the distance of the hypotenuse you would have to use to lead the target at a 45-degree angle. And you'll find that you couldn't hit that target because it ends up being a 33-mile hypotenuse. So you're going to shoot a lighthouse. The ship and the lighthouse move. Even if you tried to lead the target, you're going to fall 8 miles short because the range of the gun is only 25 miles. Think about that, people. I don't think that this ship misses targets. I don't think it's 25 miles off when it shoots at a target 25 miles away. You have to use your brain and just think about some of these things that obviate that they're full of crap. They show you Foucault pendulums and say everything moves independently underneath of an object, but then they tell you this guy floated around for hours above the Earth and jumped in the same place he took off from. You have to analyze and think on your own, and you just tell me if this makes sense to you, because it makes a lot of sense to me. Hope you have a great day.
No. The one on the left has to be an illusion. But I think we can shoot the boat on the right. The curvature chart says it's okay.
Yep, there's a kitty hawk.
Certainly not that one. That's a refracted image of a boat that's hidden below 50 feet of water. Stupid flat earthers actually think that's a boat there. No, same with that one. Don't shoot, that's a mirage.
Destroyer, and then,
ooh, that's a tough one.
That's
maybe half refraction, half real. So aim for the top half of the boat.
It's
not that one, that's refraction. There's no boat there. You're aiming at a wall of water.
We should see Seawolf coming up pretty soon, right?
Yes. Finally, the curvature chart says that one is okay to shoot.
Just keep cycling through.
Absolutely not. It's actually hidden behind something like 40 feet of water.
Yeah, there's a scope.
Damn, this is hard.
Adjusting. Nope.
Why in the hell did we even install a periscope? It's not like it's useful for any boat beyond a few miles.
Given the plethora of other information, mathematical equations on range estimation, sight alignment, sight picture, breathing, trigger control, follow through, prepping for the next shot, all these things result in quality accuracy downrange if you do them properly. Coriolis and spindrift are theory, okay? Whether you want to agree to this or not, it's somebody's mathematical theory.
Not only can you never talk about it publicly, you have to be a debunker publicly.
I'll tell the government right now. Tell you right now, if you're listening, NSA, CIA, I'm available.
You can co-opt the person and say, hey,
I swear to God, I will make fun of that crap to the end of time. I'll make up stories. I'll lie to my mother. I don't care. Well, that's a terrible saying.
Side. Let me just shut up here and let.
Yeah. Yeah.